All right, now that we had a good understanding of what a relation and a function is, specifically a function, we're going to start to look at specific type of functions. So the first function we're going to focus on is something you guys have learned about before, so it should go rather quickly. But we're going to learn about today and review a linear function. So a linear function is a function. Think of the word linear. The first four letters form the word line. So yes, on a graph, a linear function is going to form a line when graphed, but a linear function is specifically a function that has a constant rate of change. What a constant rate of change means, when we look at the inputs and the outputs, so think of my x's and my y's, a constant rate of change means that, let's say my x's go 0, 1, 2, and 3. Let's use my coin machine as an analogy again, where it goes 0, 4, 8, and 12. Constant rate of change means that if I look at my y values or my outputs in this case, that if I were to compare the change in those y values, so 0 to 4, notice that adds 4, 4 to 8 adds 4, 8 to 12 adds 4. It's a constant rate of change because the change is always the same. Constant means the same. Rate of change, we're looking at how the y values change. And notice that is true as the x values are also changing by a constant amount, going +1 every time. But specifically, we're looking at the output. So if we see a constant rate of change, we know that function is linear. All right, so first of all, I just want to know if the graph is linear or not. This should be pretty easy. Well, guess what, folks? I don't think that forms a line. So this one is definitely not linear. But in example B, that one definitely forms a line. So this one's definitely going to be linear. So it's got to form a straight line in order to be a linear function. All right, now looking at it as a table, so this is kind of what I was going through before in terms of the constant rate of change. So what we're always going to look for when doing this is we're going to look at the y values, okay? Now, before I look at the y values, the one thing I'm going to look at first is I'm going to look at my inputs. So my inputs are my x values. What I want to make sure is, again, I'm looking for a constant rate of change, but I also need my x values to follow a constant rate of change. So if I go from 3 to 6, notice that's +3, 6 to 9 is +3, 9 to 12 is +3. So that's good. That means my inputs are also going up at a constant rate. But what I want to do is I want to look at what that does to my y values. So my y values, notice I go from 36 down to 30. So this one's going down 6. 30 down to 24 is down 6. 24 down to 18 would also be down 6. Now notice this one is not going up, but it's going down. But the key thing we're looking for is the rate at which it's going down constant? And in this case, it is. So because we have ourselves a constant rate of change, so a constant rate of change, that means this function is linear. Okay? Next one, do the same thing. Again, I'm going to look at my inputs first. That's my x values. Here I go from 1, 3, 5, 7. So notice +2, +2, +2. So that's good because they're all constant. But what I want to specifically look at in order to determine if it's a linear function are my values here, my y values. So if I look at 2 to 9, it goes up 7. 9 to 20 is up 11. 20 to 35 is up 15. So notice that it's going up by different values every time. So because we do not have a constant rate of change, this one is not linear. So again, it has a constant rate of change. All right, next thing we're going to look at is what do linear functions look like as a function rule. So from a graph, obviously it forms a line. From a table, we're looking at that constant rate of change. So from the very basics, what does it look like in terms of y and x written as an equation? So there's two ways lines are going to be written. The first way is what's called standard form. When we say anything is standard form, it's like the very OG basic form. It's like buying a brand new car but getting the standard edition. Standard edition means it has no bells and whistles. It is basic, okay? So all linear functions in its basic, most simplest form, can be written like this. ax plus by equals c, where a, b, and c are going to be numbers that are going to tell us different things about the line. Okay, so all linear functions are going to look like ax plus by plus or equals c when written in standard form. But what makes lines different are when we have different numbers for a, b, and c. So here's an example of what one might look like written in standard form. We have 2x minus 4y equals 12. So my a value here would be the 2. My b value would be the negative 4. And then my c value here would be the 12. Okay? Second way in which I can relate a linear function is in what's called slope-intercept form. So you guys might be familiar with this. You learned about this in the past. Slope-intercept form, again, is written in terms of y and x. So you'll see in this one my input and my output. But instead of just a basic form, slope-intercept form, based on the words, has two things within this equation. You have the slope and what's called the intercept. Okay? I'll just highlight intercept in yellow there. So in this equation, you have the y equals mx plus b. M represents the slope. We'll talk more about that, but the slope is going to tell you the steepness of the line, okay? So in terms of this line here, the slope is going to be represented by how far the line goes down and over across certain points. And then you have what's called the y-intercept. The y-intercept is the b value that's written here at the end of my function, and the y-intercept is where that line crosses the y-axis. Intercept means to intersect and cross. So it's the second way in which it might be written. So an example would be something like y equals 2x minus 4. Where here my slope would be 2, and my y-intercept would be, I'll write that as b, would be negative 4. So just recognizing two different forms, and we're going to spend a little bit more time on each of these individually, but again, linear functions can be written in one of those two forms. All right, so pretty straightforward here. What we're going to do is just simply, I want you to recognize, is the equation given written in standard form, slope-intercept form, or something that is different. So in this first example, I have y equals 3x plus 4. So anytime you see y equals, that's a dead giveaway right here that this one is going to be written in slope-intercept form. So that is y equals mx plus b, where here again the two things that are making this different, not standard, would be the m and the b, the 3 and the 4. The second one we have 2x minus 3y equals 12. So thinking about what that form would be, this one would be standard form. So notice for standard form, how do we recognize that? Notice that x and y are on the same side. My input and output are on the same side, and it's equal to a number on the other side. So again, this would be my a, my b, and my c. So this always looks like ax plus by equals c. So in this last one, the last one, 3x equals y minus 8. All right, so is that one written in slope-intercept form? No, this one does not say y equals. Is it written in standard form? No, it does not have x and y on the same side. X and y are on opposite sides of that equal sign. So this one's not written in a special form, okay? So this one, if we were ever to see this, we might have to actually rewrite that into one of those two forms. So we might have to write that in slope-intercept or in standard form, but right there, that is not in any sort of special form. All right, next one, identifying A, B, and C. So here we're looking at standard form. So I just want to know what are the parts. So if I have 2x minus 5y equals 10, what would be A, B, and C? So for A is always going to be the number attached to x, so here A is 2. B is always the number attached to y, so here B would be that. Now, understanding that when we look at these A, B, and C, we also have to pay attention to the sign. So notice A is a positive 2, but notice with B how I see, minus 5, okay? So the minus means that my B value is going to be negative, and then C by itself, 10, I know that C is 10. So we have to pay attention to the sign that's in front of the number. Next one, I have negative x minus y equals negative 4. All right, now notice in front of x and y, God bless it, I don't see any numbers. So just a quick little reminder, anytime I don't see a number in front of a variable, there is technically a number, we just don't write it, okay? And that means if I see negative x, it's technically saying negative 1x. Same thing, if I see minus y, it technically means minus 1y, and that's going to equal negative 4. So that means my A is attached to x, B is attached to y, C is on the other side, And because of the signs, A is -1, B is -1, and C is -4. Now, last example, very similar to what we just talked about before. We have 3x equals 6 plus 2y. So notice here that x and y are not on the same side. So right away when you see this, got to have your radar on. So that means we have to take this and rewrite it in standard form. Okay? To do that, we're going to kind of use some tricks and trades of equations. Now, we're kind of jumping ahead because we are going to be reviewing how to solve equations at the end of this chapter, but some of this should be known. If I want x and y on the same side, if I want to be on standard form, that means I have to move this 2y to the left side of my equation. I want x and y to be together. Now to do that, what I'm going to do is inverse operations. This says plus 2y, so to move it to the other side, I'm going to subtract 2y. Okay? That's going to make it cancel over here, leave me with just 6. And guess what? 6 is my c value. But on the left side, I have 3x minus 2y. Now, the question is, can I subtract those two things? And the answer to that is no. Remember, when we add and subtract things that have a letter, they have to have the same letter. They have to have the same variable. So because 3x and 2y do not, they are not what are called like terms. So how do I write that then? Well, I'm just going to write it as the math shows, 3x minus 2y. I can't subtract them because they're not like terms, but now what I've done is I've rewritten this in standard form. 3x minus 2y equals 6, where a is 3, b is -2, and c is 6. So those would be my values in standard form. But again, that one tricky because we have to rewrite it in standard form. All right, last example here. This one we're doing slope-intercept form. So again, slope-intercept form is the y equals mx plus b. Here I want to identify the slope and the y-intercept. So again, the slope is always going to be the number m. It's always attached to x, and b is always going to be the number by itself, as long as it's written in the correct form. So in this first one, I have y equals -3x minus 2. So the two numbers we're looking at are -3 and -2. So the number that's attached to x, -3, that's going to be my slope. I'll label that as m. And then -2 is going to be my y-intercept b, so that would be -2. Next example, I have y equals 1/2 x plus 4. So again, I have my numbers 1/2 and 4. Written as is, my slope is going to be the 1/2 written in front, and my y-intercept is going to be the 4, the number by itself. So slope is always attached to x. The y-intercept is always the number by itself, again, if it's written in the correct form. And I say that because notice in our next example, okay, that is not written in slope-intercept form. So that means if it's not written in slope-intercept form, just like we did with standard form, we're going to have to move some things around. Now, the only bad thing is that standard form was easy. We had to move one thing around. Slope-intercept form, we have to do a couple things. The thing we're going to look for standard form, slope-intercept form, is we need to make sure our equation says y equals. So we need y alone on one side of the equation. So right now, if I were to separate this equation out to left and right, notice that my y is on the right side with a -2 in front as well as an 8. So what I'm going to do is I'm going to get rid of those 8 and -2. Now what I'm going to do real quick is I'm just going to use a property of equations. I want y on the left side just so it looks correct. So what I'm going to do is I'm going to take 8 minus 2y and move it to the other side, and 4x and move it to the other side. I can switch sides of my equation as long as I don't make them look different, as long as the order stays the same. So now what I'm going to do is I'm going to try and get y by itself. So I'm going to start off first with this 8. Now 8 minus 2y, again, I can't subtract those because this has a y and this doesn't. So that means I need to get rid of the 8 first. So I'm going to subtract 8. Okay, I'm doing the inverse operation and cancel it out. I'm going to subtract 8 over here. Now on the left side, that leaves me with -2y. Okay, and y negative is because notice I have the minus side attached to that 2, bring it down. And then that's going to equal here. Now I have 4x minus 8. Just like we said in the previous example, I can't subtract those because 8 does not have an x where 4 does. So I'm just going to write it as I said it, 4x minus 8. Okay. Now, last step I need to do here is I need to get rid of this -2 in front of the y. Now, common mistake here is to try and do the opposite. So, minus, I got to add. But understand, anytime a number is next to a variable, so when I see here -2y, that technically means I'm multiplying those things. So to get rid of it, I would need to divide by that common number. So I'm going to divide by -2, and I'm going to write it in fraction form. So I'm going to divide -2. On the right side then, what do I divide by -2? There's not just one thing, but there's two things. So right away that answers kind of my question. If there's two things, I got to divide everything on that side by -2. Cancels over here, leaving you with just y. And on the right side, I want to simplify. 4 divided by -2 would be -2, and then keep the x. Then I have -8 divided by -2. Well, that's going to give me 4, and since they're both negative, I'm going to get +4. So in the end, this is my equation, y equals -2x plus 4. So now if I write that, now that that's written in the correct form, I then know that my slope is -2 and my y-intercept is 4. So I can only identify the correct parts if it's written in the correct form. So in these last two examples, if you have an equation not written in the right form, then you just have to rewrite things. So this is kind of the basics, some of the things on linear functions. Our next couple sections, we're going to get into graphing linear functions. Again, if you have any questions, jot those down. Email me. We'll see you guys in class.